Hello dear students, welcome to a new session, and today we'll be learning about inscribed angles subtended by the same arc. Let's start with the theorem. In the theorem it says, in the same circle, the measure of all inscribed angles subtended by the same arc are equal in measure. So as you can see here, this inscribed angle ADB is subtended from arc AB, and this inscribed angle ACB are also subtended from the same arc, which is arc AB. So angle ADB and angle ACB are equal in measure. How did we know that? Angle ADB equals half the measure of arc AB, as the inscribed angle is half the measure of its subtended arc. And angle ACB, which is angle C, is an inscribed angle for arc AB. Then angle C as well is equal to half the measure of arc AB. As long as B is half measure arc AB and C is half measure arc AB, then angles C and D are equal to each other. Then angles C and D are equal to each other. Example 1, the question is asking us to find the measure of angle C and B for the first circle and measure of angle C and BDC for the second circle. If you check for the first circle, you will see that measure of angle C is equal to measure of angle A, because C and A are coming from the same arc, yes, are subtended to the same arc. So as you can see here, that the measure of angle C is equal to measure of angle A, which is 50 degrees. Why is that? Because they are both inscribed angles from the same arc DB. So angle C is 50 degrees. Okay, how can we find angle B? Let's check. You will see that angle B is an inscribed angle that is coming from arc AC. Do we have another inscribed angles subtended to the same arc AC? Yes, definitely, angle B. Yes, definitely, angle D. So, angle B, the measure of angle B is equal to the measure of angle D, which is 25 degrees. Okay, let's go to question number 2. As you can see given here that AB is equal to AD. It's given on the shape. So here, AB is equal to AD. It's given. Therefore, the measure of angle ADB equals the measure of angle ABD. Each of them is equal to 70 degrees. Then, measure of angle A equals 180 minus the sum of the two 70s, which is 40 degrees. So here, as you can see, major angle A, we found it as 40 degrees. Angle A is an inscribed angle, and its subtended arc is BD, where angle C is another inscribed angle with the same subtended arc, which is BD. Then, angle C and angle A are two congruent angles, then angle C is 40 degrees. So angle C equals 40 degrees. To find the measure of angle BDC, you will see that the measure of angle ADC is equal to the measure of angle ABC, which is 20 degrees as given. Therefore, the measure of angle BDC equals 70 plus 20, which is equal to 90 degrees. So, the measure of angle BDC is 90 degrees. Let's go to example number 2. In the opposite figure, M and N are two intersecting circles at points A and B, where AC intersects the circle M at C and intersects the circle N at D. AE intersects the circle M at E and intersects the circle N at F. How can we prove that? The measure of angle EBC is equal to the measure of angle FBD. Let's go and check. In circle M, you will see that measure of angle CBE is equal to the measure of angle CAE. Inscribed angles subtended by arc CE. And in circle N, measure of angle DBF is equal to the measure of angle DAF. Same reason, inscribed angles subtended by the same arc DF. The measure of angle FAD is equal to the measure of angle CAE as vertically opposite angles. Therefore, the measure of angle CBE is equal to the measure of angle FBD. Let's check our corollary. In the same circle or in congruent circles, the measures of the inscribed angles subtended by arcs of equal measures are also equal. See, as you can see here in these two circles, the measures of the inscribed angles subtended by arcs of equal measure are also equal. Another corollary, the two arcs subtended by two parallel chords are also equal. So here, arc AC is equal to arc BD and arc CE is equal to arc DE. Another corollary, the two arcs subtended by a chord and a tangent parallel to it are also equal. As you can see here, CE as an arc is equal to DE as an arc. Example 3, in each of the following figures, find the value of the symbol used in measuring. In question number 1, as you can see that the two arcs FD and CA are given equal to each other, then for sure, two inscribed angles subtended from equal arcs are also equal in measure. So in this case, you will see that angle B is equal to angle E, then 5x minus 40 is equal to 30. So 5x is equal to 70. Then x is equal to 14. We're in question number 2. As you can see that AB is parallel to CD, therefore the measure of arc AC is equal to measure of arc BD, which is 50 degrees. Therefore, the measure of angle BED is equal to 3y minus 5, which is 50 divided by 2, which is 25 degrees. So, to find y, you will say that 3y minus 5 is equal to 25, where 3y equals 30, then y equals 10. Let's go and check a converse of theorem 2. If two angles subtended to the same base and on the same side of it, and they have the same measure, then their vertices are on an arc of a circle and the base is a chord in that circle. As you can see here, angles C and D are both drawn on the same base, which is chord AB, and on one side of it, where angle C is equal to angle D, then the points A, B, C, D lie on one circle, where AB is a chord on that circle. Let's check a quick exercise. How can we find x, y, and z in the first circle, and how can we find x, y, and z in the second circle? In the first circle, as you can see here, that angle C and angle B are subtended from the same arc. Then the measure of angle B is equal to the measure of angle C. Accordingly, x is equal to 50. So here, this x is 50. After that, in this triangle ACE, you can easily find y. Y equals 180. Take away 95 plus 50. So y equals 35. As you can see, angle A and angle D are subtended from the same arc BC, and they are inscribed angles. Then angle D, the measure of angle D, equals the measure of angle A. Then Z equals 35. Let's move on to question 2. If you go to question B, you will see that arc DC is the subtended arc of the inscribed angle B, which is 74. So the measure of arc DC is double the 74, which is 148. So the measure of arc BC and BD are equal to each other, then each of them is 360 minus 148 divided by 2. So if you calculate it here, it will be 212 divided by 2, which is 106 each. So this arc is 106, where this arc is 106. So angle X is half this arc. So X equals 53 and Z equals 53. How about Y? As you can see that Y is an inscribed angle subtended from the same arc BC, so it's also half BC, which is half the 106, which is 53. By finishing this exercise, we came to the end of our session. Thank you very much.